This video is a review of function operations and domain. So we will complete numbers 1 through 8 only in your note packet. In this problem, we are asked to take function f and combine it, so add it to function g. So function f is 3x plus 2. And we're going to add it to function g. So we are not foiling this. It says to add here. So that means we're just going to combine the like terms. So 3x plus x is 4x. And positive 2 and negative 5 make negative 3. So we get 4x minus 3. Then we are asked what the domain is. So remember what domain is. It's asking us what values can x have. So if we look at our function right here, I have to think about what numbers can I plug in for x here, multiply it by 4. What numbers can I multiply by 4 and subtract 3 from? So hopefully you're thinking any numbers, so all real numbers. I could plug in 5 there, I could plug in negative 5 there, I could plug in 0, any number I could plug in and multiply by 4 and subtract 3 from. So that's why our domain is all real numbers. So remember we could do this also graphically. So if you have the function, you could just think about and use common sense about what numbers you can plug in for x here. But if you have the graph, so I went to Desmos.com and I asked to graph 4x minus 3. And as you could see, if you look at the graph, when we do domain on a graph, we always look from the left to the right side. So if we looked here at the left all the way to the right side, we can see that the graph is going infinitely to the left and the graph is going infinitely to the right. So the domain that we got here checks. In this problem we are asked to take function f and this time subtract function g. So we're going to take function f and subtract function g. So again, we are not doing 3x times x. We're not foiling. This is a subtraction problem here. So instead, we are going to distribute this because it's saying to take away x and take away a negative 5. So that makes it a positive 5 there. So what it's doing is taking what's inside the parentheses and making it opposite. So instead of x minus 5, it becomes negative x plus 5. And we are going to combine it now with 3x plus 2, so we're going to combine the like terms. 3x minus x is 2x, and then a positive 2 and a positive 5 make positive 7. So our answer is 2x plus 7. Okay, now we are asked to find the domain. So remember, domain is what values can x have. So our function is 2x plus 7. So we have to think about what numbers can we plug in for x here, multiply it by 2, and add 7. And hopefully you're thinking all numbers, any number would work. So all numbers, x can take on all values. Now if we look at the graph of 2x plus 7, you can see from the left to the right, so from the left it's going infinitely to the negative side of the graph here, and as you move to the right it's going infinitely to the right. So it matches the domain we said here just by thinking about it. Here we are asked to take function f and multiply by g. So we're going to take function f and multiply it to g. So since here we are multiplying, that's why I'm going to FOIL here. So I'm going to do 3x times x and then 3x times negative 5. 2 times x, and then 2 times negative 5. Combine like terms. So we get our answer of 3x squared minus 13x minus 10. So now we're asked for the domain. So domain means what numbers can I plug in for x? So what numbers can I square, then multiply by 3, and then here multiply by negative 13, subtract 10, and hopefully you're thinking any number would work. So our domain is all real numbers, because we can plug in any number here and here. So if we take a look at the graph, we can see if we go from the left to the right, as we here it's going infinitely to the left, and then it's going infinitely to the right. So all real numbers, which is what we have here. Alright, here we're told to divide function f and g. So if we take function f, which is 3x plus 2, and divide it by x minus 5. So we can't simplify 3x plus 2 divided by x minus 5. So just to make sure we understand, if instead it said x squared minus 4 over x minus 2, we would be able to factor the numerator to x plus 2 times x minus 2, and then we'd have matching binomials here, and we would get x plus 2. But that's not our problem here. In the problem here that we're given, we cannot factor the numerator, we cannot factor the denominator, so nothing's going to divide out. We cannot divide this x with this x because it has the plus 2 here and it has the minus 5 here. So this x minus 5 is glued with that, or that x is glued with that minus 5, and this 3x plus 2, that's together, and we need another 3x plus 2 to be able to cross it out. So if you're like, that's all we have to do? Yeah, that's showing math knowledge that you know that we can't divide out those x's there. So now the domain. So the domain is what values can x have? So we know that when we have fractions, we cannot have in the denominator, the x minus 5 cannot be 0. So we don't want the denominator to be 0. So we're going to find out what number will make it 0. And we could see that the number x cannot be is positive 5. So that means x can be any number. So if I look at a number line, for those who are visual, it cannot be 5. But it can be any number less than 5 and any number greater than 5. So if we write that in interval notation, to the left it's going to the negative side, so negative infinity, and then it stops here at 5, but we can't include 5 because it will produce 0 in the denominator, union anything greater than 5. So now if we take a look at the graph of this function here, you will notice on the left, it's going infinitely to the left side. And then as it goes to the right here, you could see that it's getting closer and closer and closer to 5. But it doesn't, it will not have a point using x as 5. And then over here, as we go to the right, it's going from 5, it's approaching 5. And then it's going on and on infinitely to the right side. So it matches what we got here. Alright, here we're given a new value for function f and function g. So we could see here, now it's saying to add f with g. So we're going to take f, which is the square root of 2x, and add it with g, which is x squared minus 4. So adding here, we're going to combine the two together, and we don't have any like terms. So all we have is I'm going to start with the higher exponent, so x squared, and then I know this exponent is to the 1/2 power, so that's going to come next, and then the constant at the end. So we can't combine any of that. So yeah, if you're like, that's all I have to do, yeah, that takes knowledge knowing you can't combine terms that are not like terms. So now our domain. Our domain is what values can x have? So if we look here, we have x squared. Well, x can be any number here. You can square any number, negatives, positives, zeros. But the problem is right here. We have a radical here. So any number can go in for x here, but we have something to worry about here. So we know that what's in the radical, the 2x is inside the radical, has to be greater than or equal to 0. Because in the radical, we don't want a negative number. Because if we have -9, then we're going to have 3i. So when we're working in the real number system, we want the number inside the radical to be greater than or equal to 0. So now we solve, and we get x is greater than or equal to 0. So we flip the symbol when we divide by a negative, but we did not here. So x has to be a number that's greater than or equal to 0. So if I draw a picture of that to visually see, here's 0. It says equal to, so that's how I know to put a solid circle there. And it says the numbers for x have to be greater than. So now to write my answer, I'm going to go from the left, and I'm putting a bracket because it could equal 0. And then any number greater than 0 could go into this problem here and be okay. Now if we take a look at the graph, here's what it looks like when I ask Desmos to graph it. And you can notice it starts at 0, right here. And then to the right, it goes on and on and on. So the graph never comes over here. So it matches what we got here for our answer. Alright, here we are told to divide. So to take f of x and divide it by x squared minus 4. So we can factor the denominator to x minus 2 times x plus 2, but that's not going to cause this to divide out with this. So we don't need a factor because that will get us nowhere. So there's nothing that can divide out here. So this is what we're going to have as our answer here. Now if you write your answer like this, this is not wrong. You can also have it this way. Whoops. All right, now the domain. So when we look at this, we know that the denominator can never be 0. So x squared minus 4 cannot be 0, because then it will be undefined. So we're going to solve this. You could use the quadratic formula, you can factor. I'm going to use the square root property here and get x equals positive 2 and negative 2. That's what x cannot equal. Alright, but we have another issue here. We have a radical. So we know that 2x, what's in the radical, has to be greater than or equal to 0. So we have two things to worry about here. So if we draw our number line here, we have that x cannot be negative 2 and x cannot be 2. And we have 0 here in the middle from this. And this one is saying that x could be 0, but it has to be greater than 0. So x can't be 2 and negative 2, and x has to be greater than or equal to 0. So if we look at our graph here, this will help us see where our solutions are. So our solutions are where they are both shaded. Okay, so here this one says x can be any number. So it could be any number here, any number here, any number here. But it can't be -2 and 2. So what they have in common here is they both, right here, have 0. And then they both have all of this here. But it can't be 2 because of this. And then it could be any number, they're both shaded here. So it could be union, any number greater than 2. So the reason why we don't need to include this -2 right here is because -2 can't go right here. -2 is not greater than or equal to 0. So none of these numbers over here, none of these numbers will work because it says here that they have to be greater than or equal to 0. So we can eliminate this whole part of the graph. So they all have to be greater than 0. So all of these numbers are greater than 0. But this one here says x cannot equal 2. So that's why we start at 0 here, and then it could be any number here, and then not 2, so that's why we have to stop there, and anything greater than 2 will work. Let's take a look at the graph of this. So if I look at it visually from the left here, it starts here at 0, and then it keeps going and going and going, but it's going to approach here 2. But it can't be 2, it's going to approach it. And then over here it's approaching 2, and then it's going on and on and on. So it matches what we got here as our domain. In this next problem, we are asked to add f with g when the value of x is 2. So I will show you 2 different ways to do this problem. So one way is we are going to take function g and function f, and we are going to plug in 2 into both of them. So we're going to evaluate here, exponents first, then we're going to multiply, and we get 9. And so now we're going to do the same thing for g. And we get 14. Well, we're asked to add the values. So we're going to take the 9 and add it with the 14. And we get that the value is 23. So this is one way. So you plug in the number. So instead of x, it wasn't g of x, or f plus g of x. It was telling us to use 2 instead of x. So I plugged in 2 into each function and then added the 2 values. The other way that we could do it is that we could take function f and add it with function g. So we can combine our like terms here, because it says to add, just combine them. We're not multiplying here. Combine the 1 with the 4. And now we could plug in the 2 for the x's here. If we do that, we should still get 23. And we do. So 2 different methods to get the same answer of 23. In this problem, we are asked to take f and g, and since they're next to each other, it means multiply, and the x value we're going to substitute is 3. So one way to do it is to plug in 3 into both functions. So I'm going to take x plus 4 and plug in the 3 for the x here. and then take function g and plug in the 3. And here we get 7, and here we get 15. And it said to multiply the two values. So we would take 7 times 15, and we would get 105 as the value of f times g at the specified value of 3 for x. Now another way we could do that is we can take f, which is x plus 4, and multiply it by g, which is 5x. So we could simplify this here. We can distribute, and we would get 5x squared plus 20x, because we're doing 5x times x, and then we're doing 5x times 4. Okay, now we can plug in the 3. So we could do it first, or we could do it after. So we would get 45 here and 60 here, and combine them, and we get our 105, which we got by plugging in 3 into each function first, separately.